hit the road with the motor.
Hey, affirmative, we want to ride down the middle of the road. It's kind of a grassy two-track road, 1,400 feet, head 005 degrees, coverage level 3.
My name is Rachel Hansen, and I work for the Region 5 module of Aerial Firefighting Use and Effectiveness. My background in fire started in 2003. I spent about 9 seasons on a variety of Type 2 and hotshot crews. I worked for both Wolf Creek Hotshots and Asheville IHC. In August of 2014, I was hired to work for the Region 5 module of AFU that I currently work on.
Many kinds of scientific experiments were conducted and many chemicals tested. Research prepared the way for efficient use of this new tool.
When we look at the history of the agency, we have a lot of studies that have been done about how we use our aircraft. What all of them have done have gone back and looked at previous records. We can see how they're being ordered and where they're being deployed to and things like that. But we don't have anything that actually captures what they're doing on the line or how effective they are or what the outcome is. The history of AFU started because
Forest Service wanted to look more at how we were using our aircraft and how effective we were being with the aircraft. This program was kind of developed to start looking at ways to look in the field at how we could collect data on performance and effectiveness of our aerial fleet.
Let's just go the full load there.
My name is Sean Wildhaber, and I work on the Region 1 Aerial Firefighting Use and Effectiveness module. I got my start with the Forest Service in 2002 on a district crew, and I quickly moved to interagency hotshot crews where I spent 12 years. In 2015, I got on permanently with the Aerial Firefighting Use and Effectiveness program. Most of the individuals on our modules are highly qualified.
our quals range from ICT-4 all the way up to ICT-3 and qualified air attack, who've come from smoke jumpers, engines, hotshot crews, Type 2 IA hand crews, and wildland fire modules.
The operations side of what we do really helps us to integrate into what we're doing on the ground because we're talking the same language as the other individuals that are out there in the field.
You have boots on the ground firefighters interact with individuals in an operational setting who can stay safe and who can collect data and understand what they're looking at.
So I've been the incident commander of probably maybe a handful of large incidents where AFU folks have interacted. You know, oftentimes it's opportunity dependent for AFU. You know, what stage of an incident are you in? What's going on with the incident? You know, are they there at a time when it's still evolving, or are they there at a time when it's stable or maybe declining in activity? Every incident, I think, affords a different opportunity for both AFU to get data, but also to interact in real time, you know, with fire managers and line supervisors. I've had some good conversations with people like Chris Bolts on incidents about what it is that they've seen, what they're seeing in real time, or you know, maybe a day or two later of what it is that they gathered. It helped to either reinforce what my thoughts were about why we did some of the things we did, made the decisions we made. Maybe we ended up with a slightly different outcome, and I, you know, learned something from the data they at least preliminarily collected. They've generally all been good experiences and not impactful to our operations.
AFUE modules are fully funded and self-sufficient. So when we arrive to an incident, that incident doesn't have to worry about a cost that's incurred by us being there. We're there to do our job, but we're not there to impact that incident or the management team in any way.
We go to briefing just like every other resource on the fire. Our group, our module, is going to try and make contact with as many division supervisors as we can and explain what we're doing. Once we go out onto the line, we make contact with division supervisors, we maintain communications, we do all of the typical things that a resource would normally do on a fire, except we don't engage in operational suppression. We're there specifically to watch tanker drops or helicopter drops or whatever's going on with the aerial resources.
AFUE modules can generally arrive on an incident before, during, or after. For us, the prime time to actually be there is before or during, so that we can actually watch aircraft as they're working. We can hear the interactions of aircraft with ground resources. We can listen to air, so listening to air attack or an ASM that's coordinating those aircraft that are, making retardant drops or water drops from rotor wing. That's the best time. We can arrive at an incident after, and we can still provide pretty good data as long as we are talking to the role players that were on the incident at the time that the events were occurring.
The questions that AFUE is looking at: how are our aerial assets being used? Are they being used effectively? What does our fleet need to look like now and in the future?
Collecting real-time data on incidents to try and capture as much as we can of what we're doing with our aerial fleet and how that corresponds with the ground resources and how they work together to be effective.
So the air show is really there to support the boots on the ground that are fighting fire, prepping roads, burning out, protecting structures. And depending on how we employ those aviation assets affects probability of success for firefighters on the ground.
So difficult to measure effectiveness because it gets applied it can be applied in a few different ways. Direct application right to the fire itself, the fire's edge itself.
We split a load, half inside the black and half into the green, to help slow a fire down when a crew is trying to get in.
Where we intend the retardant to sort of act a bit like a suppressant and put some fire out, but also like a retardant and slow or check fire spread.
But typically what we do with retardants is we pre-treat in advance of or in support of direct and indirect line construction.
Say we're out on the line and we have a lot of tankers coming in to drop. Generally what that looks like is we have one person engaged in operational situational awareness. And that's usually, for my module, that's usually our module leader. He maintains situational awareness, which means he's not actively engaged in collecting data, so that the other two, myself and the other crew member, can focus on collecting data. And what that looks like, one of us is engaged in note-taking, the other is engaged in actual data collection, which generally is on an iPad, and we use a collector application, and that allows us to visually and geographically represent a drop in a landscape that has 63 attributes attached to it. As ships come in and drop, we try to capture all of that.
We're pretty much doing the same type of work that field observers do. There's a caveat to that. Obviously, they're not mapping retardant generally, or looking at rotor wing and mapping rotor wing stuff, but fire perimeters, dozer lines, burnout operations, all that type of stuff, we're mapping that. We generally walk, drive, or fly perimeters because we have to have accurate perimeter mapping. We found there's great benefit to flying an incident as well, because it's difficult when you have a canopy to see how the drops have been laid and how they progress, but from an air perspective, you can really see spatially how they've been put down.
What that specifically means is that we look to capture not just what the aerial assets are doing, but why they're being ordered, what they're actually doing when they get there. What is the outcome of their actions? And we're also looking at that in conjunction with what ground people are doing, what the needs are on that fire, what's happening in the moment. And we're also looking at weather, terrain, all of the factors that go into the dynamic environment of wildland firefighting. We try to paint an entire picture.
Then the data is ready to go through statistical analysis so that we can look at probability of success.
So that when we do look at what are our aerial assets doing and were they successful or unsuccessful, we understand as firefighters and fire managers that it's not a black and white scale of success or failure, but there in between is a whole gray scale where operational people and aerial assets can contribute to the success of a campaign even if one piece of what they're doing may not be successful.
As you're measuring effectiveness, I think one of the first things is trying to understand the intent in which it was applied.
When we assigned outcomes, we try to align the outcomes with what happened based on the original intent. We try to figure out exactly what they wanted to do with that aerial resource and whether or not they felt like it met their needs.
As capacity and need is constantly evaluated, there's been a lot more subjectivity and effectiveness over the years. And so to try to begin to get to a place where we can be a little more objective is an important task, because I do think that there's a lot of room for growth in being more effective in how we apply retardant.
So by having quality information, by having good data, good numbers, good quantifiable terms, we can speak more intelligently to our line officers and our agency administrators and our public about our probabilities of success. And that equates to, all that data equates to a stronger training program, which then equates to a stronger foundation for our firefighters to be able to make sound decisions and have the tools that they need and be able to utilize them properly.
So to the operational fire community, the findings are going to be important because we're going to really be looking at the probability of success. We are only scratching the surface of what is there as far as, looking at how many times have I been in this situation before. So that's what our data is going to provide. How many times has this situation happened in the past? And how successful have we been in implementing tactics? So with the data that we're collecting, there'll be abilities to look at decision support tools in the future that can provide that information. Now, is that going to work in every scenario for every incident? Probably not. But what it's going to do is provide you with a tool that's going to allow you to have a better probability of success because you already have seen examples from the past that are bringing you to the future of how well can I implement tactics with the resources I have and how effective am I going to be.
I think that the AFU project is a wonderful effort to try to move us in a direction where we can be a bit more objective in how we view the effectiveness and subsequent value of retardant, but to be able to break it down farther and remove the layers of subjectivity to get more to the core of objective approaches with retardant use is really where the value of that project and that effort is.
As I understand it, the aerial firefighting use and effectiveness study is designed around helping answer questions to not only politicians, but to our agencies, our fire managers, and to line officers. Not all the questions that we have are known. Sometimes we don't know what we don't know, and we don't know what we need to ask. But what we do know for certain is that every year we're going to have fires, and every year with people encroaching into the urban interface, with more structures being built, there is more potential for urban interface conflicts, which is a big priority. If we're waiting for an air tanker to come across 2 geographic areas, our fire now has time to establish a foothold and increase our resistance to control. If we have one that's waiting 30 minutes away, obviously our probability of success is much higher. Aerial firefighting use and effectiveness study, in my eyes, can help us in a couple of ways. One, as a duty officer, it can provide me with some data, some facts, and some quantifiable tangibles that I would be able to sit down with, let's say, a new line officer or a new district ranger and walk through why we do certain things under certain conditions and why we don't do certain things under certain conditions. Another one from an aerial supervision perspective is with the influx of technology that we have with mobile devices, with electronic flight bags, with thermal imaging capabilities out of aircraft. I see some opportunities into the future of being able to actually communicate statistical probabilities of retardant working under given situations. So as an aerial supervisor, understanding that when fire reaches a certain intensity, we all know. Those of us that have been on the ground and been out there digging line and spending years sleeping with our heads in the dirt, we can understand, because we have that intuition, we have those slides built, that this fire is going to continue to burn until something changes. But we need to be able to quantify what that is, the intangibles. Why won't retardant work under these situations, or why would it work under certain situations?
We teach our younger folks coming up the things that we know as individuals, how to manage fires, how to manage people, what you do when you order an air tanker. But we haven't really institutionalized a lot of that knowledge. One of the shorter term goals for this program is to start looking at how we can better pass on that knowledge. One, to define what makes for a successful drop, what makes for a successful use of an aerial asset. We want to come up with a way to better pass on knowledge and to teach people how to really understand and use the aerial assets that we do have so that they can make better decisions and so that they can also support the decisions that they are making.
Training is one of the most important components of our entire operation. Training sets the standard. I think of a career as building a house. You have to start with a strong foundation. If you build a weak foundation and you continue through your career with that weak foundation, the house isn't going to last very long. It's not going to be very durable or resilient. If you have a strong foundation in training and you've received quality instruction and quality mentorship, it's going to set the tone for your entire career. And then people, as they move into middle management positions and leadership positions, will then in turn reflect back on that and pay that forward. So the national fire community needs to stay tuned and be ready to find more information out from the data they're collecting, the information they're gathering, and how we can do business better.